Hello, Honors Algebra 2 Trig. We are back in action, and today we are going to wrap up law of sines and law of cosines by looking at how you are able to calculate area with these two formulas and looking at something called the ambiguous case. And that ambiguous case is only applicable for the law of sines, not for the law of cosines. So just law of sines, and it's when you have the angle side case, you know, the one that's a pain. So anyway, let's go ahead and switch over to screen share here. So I'm working on that for you, and hopefully technology will allow us to do that. Here we go. So if you want to print out the notes, as normal, you can. Otherwise, you're welcome to just kind of take notes alongside me. But again, day 12, we're using law of sines and cosines to calculate area and talk about this thing called the ambiguous case. Okay. So area of a triangle, there's one way using sine, and there's another way to calculate the area of a triangle using cosine. And the deal is on these is that neither of these are for right triangles. These are for triangles that are non-right or non-right triangles, okay? So when you're doing these, there's three different versions of the law of sines area, and you can kind of look there. So it just kind of depends on what you have, but you have two sides, and the included angle is kind of the deal with that. So when you talk about finding the area for these different things, if you're given angle A, then you have to have side B and side C. That's kind of what's going on here, okay? So it's not that you need a matchup of an angle and its opposite side like you did to use law of sines, but just to use the area formula, this is kind of how that works out. Okay. So here's our first one. It says the black-necked stilts are birds that live throughout Florida and surrounding areas, but breed mostly in the triangular regions on that map. Find the area of that region, okay? So you'll notice that they're giving you angle A, and they're giving you side C and side B, okay? So if you're looking at that, I would use that formula 1/2 BC sine A. And so the area would be 1/2 times side B was 125 miles. Side C was 223 miles. And then the included angle, we take the sine of that, which is 54.2 degrees. Now make sure your calculator is in degrees, not in radians when you plug this in. I'm getting 11,304.2020 square miles. Okay, so that's that problem. Okay, the other way that you can calculate area is using Heron's formula, and it looks something like this. The area of a triangle, and you're only given the sides, so side is what you're dealing with here, is the square root of this thing called S times S minus each side as you kind of go around, but it is a square root. The thing you need to know is that S is not the average of the sides. It's actually the sum of the sides divided by 2. It's called the semi-perimeter, or half of the perimeter. Hey, that's what it says on there. Crazy. All right, so let's go ahead and use that. For this particular problem, it says the intersection of 3 streets form a piece of land called a traffic triangle. Find the area of the traffic triangle shown. So we obviously have side. We don't have two sides and an included angle, so we have to use Heron's formula. And so we'll start by calculating what S is. S is the semi-perimeter, so it's 1/2 170 plus 240 plus 350. And half of 170 plus 240 plus 350 is actually 380, okay? So the area, they're saying, is the square root of 380 times 380 minus 170 times 380 minus 240 times 380 minus 350. Okay, so you can plug it into the calculator, and I'm getting 18,307.3756 square yards. Okay, fantastic, wonderful. Let's go on to this thing called law of signs, or the ambiguous case. The ambiguous case basically comes from the angle side side. And so back in honors geometry, when you were talking about congruent triangles, your teacher said that you weren't allowed to use the angle side side case, or they probably said the side side angle case. But the deal is that the angle side side case, or the side side angle case, basically can give you either no triangles, one triangle, or two triangles. And so that's why it's a little bit more of a difficult type of thing to think about, okay? So as you kind of go through on these types of things, if you're given an angle and a side, basically what that means is that when you talk about a triangle, again, these are not right triangles. If you're given an angle and a side and then another side, you're always going to be given a pairing where you've got an angle with its opposite side, okay? And so the question will always become, really, is this side, is it big enough to make a triangle? And sometimes it's big enough, sometimes it's not. If it's not big enough, then you end up with no solutions. If it is big enough, you could end up with either one solution or two solutions. And that's what we have to look at today, okay? And so when we compare these things, you're going to find that we look at, that's side A, how does it compare to B times the sine of angle A? Okay, and that's kind of what we're going to look at each time when we kind of go through things. Okay, so let's start off with the angle that you're given is a small angle. It's an acute angle. Okay, well, if you have a situation where, look, there's your A, if A is equal to B times the sine of A, you actually have a right triangle, and that means you have one solution. So if they're actually equivalent to one another, whoops, you actually get one solution on that. Let's try that again. Boom, boom, boom. Hey, there we have all of it. Okay, so if you have an acute triangle and A is smaller than B sine A, that means that A is not big enough, okay? When it equals A, that's when you have the right triangle situation. But if it's too short, this is when you have no solutions, okay? All right, so here we have the equals case. Here we have a less than case, and then we also have a greater than case. And actually we have two of those. So again, we're still dealing with a 90-degree or an acute angle, so it's less than 90 degrees. When A is bigger than B sine A, you are able to make at least one triangle, okay? At least one triangle. The deal is this, if the matching pair that you have, that side that goes across from the given angle, if it's big, if it's the bigger of the two sides and that side's the small, then you're only going to have one triangle, okay? Okay, now here's the deal. If this side is actually the small side, and the other side that doesn't have the pairing is the big side, this is where you can get two cases. So we need to kind of know, how do you figure out how many solutions you have, but also how do you figure out the solutions when you have those? So if A is smaller than B, but A compared to B sine A is big enough, that's where you get two cases, okay? All right. So let's kind of go up and let's try some problems. Oh, before we do that, if A is a oblique or obtuse angle, okay, if A is obtuse, this part's easy. If A is obtuse, okay, and you have that A is smaller than B, so if this angle is obtuse and this side is small versus this side is big, that is an impossibility, right? If you have an angle that's bigger than 90 degrees, it should be the biggest angle in a triangle, which means it should be across from the biggest side. And so if it's not, you have 0 solutions. Okay. And if your big angle, right, if it's bigger than 90 degrees, it has to be the biggest angle, is across from the biggest side. So if this is big and this is small, that's what we expect. That's kind of the normal way to do things for a triangle. And so that'll be okay. That'll be one solution. Okay. All right. So let's kind of go through things and see how things go. Okay, so we've got 4 problems, and then this is a printout of everything. You've got this, I think, as an option for you to print off in your, oh my gosh, what's it called? In Schoology, okay? So these are all the possible different types of triangles. Today we're focusing on this one, and so the side-side angle kind of version. And on the back of this, or on page 2 of this document, it goes through all of those different cases that we just talked about. So again, like what happens if A is less than 90 degrees? So what happens if you have an acute angle? You can have no solution, or you can have 1 solution, or you can have 1 solution, or you can have 2 solutions. And if A is bigger than 90 degrees, you can have no solution or 1 solution. Okay, so that's just kind of a nice little handy thing to have. I know the question here, if we've got 4 of these, says, hey, how many solutions do you have? But I really need you to be able to figure out the solutions if you've got them. And so we're going to kind of add to that. So how many solutions does it have, and solve the triangles? Okay, so I'm going to draw myself a picture of what's going on here. In this triangle, we'll make this large X. Okay, hang on, go away. This is large X, and then so this is little x equals 4. And I'm going to make this angle Y, and so this is 5 for side Y, and this is 27 degrees. Okay, so the question is this side big enough? Does it make a triangle or not? How does 4 compare to 5 times the sine of 27 degrees? Is it big enough? And I would tell you that if you plugged into your calculator 5 times the sine of 27, you're going to get 2.27. And so I would say that this side is big enough to make a triangle. Okay. Additionally, the 2 sides that you compared, this is the large side, and this is the small side. And so what happens here is that this side might go this way, but it could also create this situation. Okay. And so you kind of have 2 triangles here that you need to be aware of. The black triangle looks like this. So there's 27 degrees, there's 4, there's 5. And then the other possibility now is that this would be 5, that's 27, but this could be 4 that's swung in here. And so we kind of need to take both of those things into consideration. You will always be able to find this black triangle first, because this is an acute angle. And when you do law of sines, it's really only good for acute sides. So it would find this angle Y first. You can see over here that this angle that's left is actually an obtuse angle. And so that's why we'd have to find that as the other case. Okay, let's go ahead and find our black triangle case. And so here we go. We have, let's see, 4 over the sine of 27 degrees is equal to 5 over the sine of Y. And so we're trying to find angle Y first, so I'll cross multiply. 4 sine of Y equals 5 times the sine of 27 degrees. I'll divide by 4, and that gives me the sine of Y. Now we want angle Y, and so we'll actually have to use the inverse sine of that. So it's the inverse sine of 5 times the sine of 27 degrees over 4. And we do need to plug that into the calculator. I strongly recommend you'll have parentheses here. I would put parentheses around the whole top and parentheses around the whole bottom as you plug those into your calculator. And I get that angle, that acute angle, is 34.5753 degrees. Okay. All right, and we're going to use that for our second case, just so you are aware in a little bit, okay? Now we need to find angle Z. Well, angle Z is the remaining angle, and we know we have 180 degrees in a triangle, so we're going to subtract off angle X, and we'll subtract off this angle Y, 34.5753, and we find that angle Z is actually 118.4247 degrees. And then to finish solving this triangle, now we need to find the third side, which would be side little z. So I'm going to do z over the sine of 118.4247 equals, I'm going to use my x's. So that's a 4 over the sine of 27 degrees. And I'll cross multiply here and get the sine of 118.4247. That'll cross out with that. And I find that side z, side little z, is 7.7486. Okay, so that's one triangle. It's the givens and these three things, okay? Let's try this purple triangle and try to figure out what's going on there, okay? So here's the deal. We figured out, based on the black triangle, that was our 34-degree angle. So the question is, what is this other angle that's right there? What on earth could it be? Well, I will tell you that when you talk about taking the inverse sine, and you got this angle, that's in the first quadrant, okay? Well, when you're talking about sine is positive in the first quadrant and positive in the second quadrant, right? So we were able to calculate out this 34.5753 degree angle over here. We need to find the corresponding angle in the second quadrant. In other words, I want the same reference angle, and that's where that 34.53 whatever comes into play. And the question is, what would this angle be? What's the other side of that? Okay, so to get our other angle Y, I'm going to take, so we're down here, angle Y, 180 minus 34.5753. And what I find is that my other angle Y would be 145.4265 degrees is what we're left with, okay? I think I did that somewhat wrong. Something's not right. I think we're a little bit off on those. Shoot, which means my calculations are going to be off. So, hey, I'm recognizing this. I kind of screwed things up, so that, and I'm not going to have time to go through and calculate. So I recognize that this is a little bit off in our notes, okay? But we're still going to keep using it because that's what I have answers for, and I don't want to have to re-edit this video. Okay, so there's angle Y. We have to find angle Z. Angle Z is 180 degrees minus angle X and minus angle Y. I'm going to use my incorrect angle Y for this because, again, I'm not going to record. So 180 minus 27, and then minus this 145.4265 means that angle Z is 7.5735 degrees. Okay, and then we still have to find side Z as well for our second triangle. And there's little side Z. Side Z should be opposite angle Z, and it will be the smallest of our sides. Okay, so I'm going to go back and use law of sines for that. So I'll say Z equals, or Z over the sine of 7.5735 degrees equals, I'm going to use my x's because that's what I started with, and I know I haven't screwed those up, so 4 over the sine of 27 degrees. So if I want to find side Z, I'm going to do 4 times the sine of 7.5735 divided by the sine of 27, and I'm finding that that side is 1.1612. So those are our two triangles for the angle side-side case. All right, continuing on, let's go to example 2. Again, how many solutions do we have? And if we have a solution, what actually is the solution? Okay, this is an acute angle. And so if we draw this, again, there's my 34-degree angle. So this is 34 degrees. This is angle B, so side B is 2. And this has got to be angle A because A is equal to 4. Okay, so the question is always, is this paired angle big enough? So what's 4 times the sine of 34 degrees? How does 2 compare to the sine of 4 times sine 34? And that's 2.2368. And that means that this side is not big enough to form a triangle, so there are no solutions. Okay, fantastic. Carrying on. All right, on example 3, we have angle A is obtuse. So here we go. So this is 112 degrees. Okay, that means that side A is 18, and we'll call this angle B, so side B is 12. All right, so you don't have to do anything with this one. It is the bigger side across from the biggest angle, right? We know for sure that this is the biggest angle. Is 18, right? 18 bigger than 12? Yes. So we know we have one solution here. If we have an obtuse angle, we can either have no solutions or one solution. So we definitely have a solution here. And so now we just proceed as normal. Let's do our A pairing. So 18 over the sine of 112 degrees equals 12 over the sine of angle B. And we'll just go through and solve it like we normally would. Let's cross multiply. So 18 times the sine of B equals 12 times the sine of 112 degrees. Divide by 18. And so that means I'm left with sine of B. I want regular B, so I'm going to do sine inverse of 12 times the sine of 112 over, over 18. I'll put all of that into my calculator. I get that angle B is 38.1792 degrees. Okay? So that's 38 degrees. Now we need to find our third angle and our third side. Third angle, third side. So our third angle will be angle C, and we'll take 180 degrees in a triangle, and we'll subtract 112 degrees and this 38.1792 degrees. And I find that angle C is equal to 29.8208 degrees. Okay? And so the last thing we have to do is find side C. And side C, we'll do C over the sine of 29.8208 equals, use the pairing you were given with. So we were given angle A. So let's go 18 over the sine of 112 degrees. That means that side C is 18 times the sine of 29.8208 over the sine of 112 degrees. And if you plug that into your calculator, I believe you get 9.6542. Okay. All right, one more example for good measure to make sure that we really actually know what we're doing here. Here is another acute triangle situation. We're given angle A and side A. So angle A, this is kind of more accurate here. Angle A is 70 degrees. Side A is 155, 155. And then side C, we'll call that C, is 160. So is 155 big enough to form a triangle? That's the question. So 155, how does that compare to 160 times the sine of 70 degrees? So 155 compared to, if I plug that in, 160 times the sine of 70, I get 150.3508. So guess what? That side is big enough to form a triangle. So that's good. So this side can form a triangle. And since this side is the small side, actually it can form two triangles. It can either form that triangle, which is the obtuse angle, or the given triangle that started with, okay? Here are our optional triangles, okay? So this is 70 degrees, this is 155, this is 160. So this angle C would be an acute angle. And so that's what we'll look for first, because law of sines will always find us an acute angle. Then we will go back and we'll still have 160 and 70 here. There's 70, there's 160. But then what we're going to find out is that this 155 could swing inside. And if it does, then it creates not an acute angle, but an obtuse angle for angle C, okay? All right, so let's go ahead and find, I'm going to erase this so that I can have enough space here. Let's go ahead and find our black angle first, our black triangle information first. So I need to find angle C first. So 160 is side C, so 160 over the sine of angle C equals 155 divided by the sine of 70 degrees. So if I cross multiply, I've got 160 times the sine of 70 equals 155. Sine of C, I'll divide by 155. That leaves me with the sine of C. So sine inverse of all of this, 160 sine of 70 degrees over 155 equals angle C. Again, law of sines can only give us an angle in the first quadrant, so it has to be acute. I'm getting 75.9314 degrees is angle C. Okay, so the other thing is we have to find is angle B and side B. How do we find that? Well, if we want to find angle B, there's 180 degrees in a triangle. We know that we started with a 70-degree angle for angle A, and then we just found angle B to be 75.9314 degrees. So that means that side angle B, is 34.0686 degrees. And then we need to use that to find side B. So B divided by the sine of 34.0686 should equal, and I'm going to use my giving pairing, which is the A, so 155 over the sine of 70 degrees. We can cross multiply. We get 55 times the sine of 34.0686, and all that's divided by the sine of 70 degrees. I'm finding that the first side B is 92.4012. Okay, a good way to check these is to make sure that the smallest angle is across from the smallest side and the biggest angle is across from the biggest side. And that's good for what we've got right now. Angle for the black triangle, we're good to go. Let's find the pink triangle. So for the pink triangle, we found our first quadrant angle. We need to find the second quadrant angle. Okay, so for the second angle C, or the second triangle, I'm simply just going to take and find the supplement. 180 minus 75.9314 will do it for us. This gives us our second quadrant angle. Okay, well, that second quadrant angle is 104.0686 degrees. Okay, so now we have to find angle B in the pink triangle. So angle B is 180 minus 70 minus angle C, which is the 104.0686. Angle B ends up equaling, I believe, 5.9314 degrees. It's teeny tiny. Okay. All right, so this little angle B is super, super tiny. There's angle B. It's really, really tiny up there. Okay, let's find side B. And again, we'll use law of cosines for that. So side B divided by the sine of 5.9314 is equal to our pairing that we like that we were given, 155 over the sine of 70. Okay, so side B is 155 cross multiply times the sine of 5.9314 divided by the sine of 70. and angle B ends up, or sorry, side B ends up being 17.0453 units long. Okay. All right, that is it. That is all. Here is your homework. It's about finding area and finding the ambiguous case. And that's what I got for you. You guys take care, and we'll talk to you soon. Bye.